All right, welcome back. We are going to go over the first new unit since this online teaching started, Chapter 10, which is Circle Geometry, specifically 10.1, Exploring Angles in a Circle. So we're just going to go over some of the notes here. You can find these notes on the website and print them off or just look at the PDF, but I just want to go over a couple things quickly with you here. So first of all, some terms to know. A chord is a line segment with both endpoints on a circle. So what that means, if we look at the diagram here, that is a chord because both of the endpoints are on a circle. So anytime we have a line that touches one end of a circle and is drawn straight across, whether it's through almost the middle or on the outside or at an angle, anytime we have this, those are all considered chords. All right. So next up, a central angle is an angle formed by two radii of a circle. So all that means is that we have one radius here, another radius here, and that forms an angle. So this angle here is the one we would find. So because they are both radii, the plural of radius, that makes this a central angle. So another quick example, anytime we have a radius of the circle here, that would be the central angle. Okay, and the last definition here is the inscribed angle. And that is an angle formed by two chords that share a common endpoint. So they have to be chords, which means they go all the way across the circle and then all the way out. But because they share this common endpoint, that makes this angle an inscribed angle. So in the other example here, these are the two chords, but they share this common endpoint, and that makes it inscribed. All right, sounds a little challenging, but we'll catch on to it pretty quick here. So a couple characteristics to keep in mind that we're going to go over right now. The inscribed angles subtended by the same arc are congruent. So first of all, the word subtended just means that they share the same arc. Okay, so they basically have the same endpoints. And congruent just means the same for angles. Okay, so it means if two inscribed angles have the same endpoints, then their values are the same. So BAD is the same as BED. So let's just quickly look at this example here. BAD, so we start at B, we go to A, and back to D, is the same size as BED. So we'll start at B again, go to E, and go to D. And so what this is saying is that these two angles here are the same value because they have the same endpoints, or are subtended by the same arc. Okay, and that will work with any scenario. So if I have an inscribed angle goes all the way across like this, and I'm not meaning to draw it squiggly, that's just this pen I'm using. If it has the same endpoints, these endpoints with the same arc as a different inscribed angle, let's say this one, we can deduce that these two angles here would be the same. Okay, because they share the same arc. All right, the second rule here is that the measure of the central angle is equal to twice the measure of the inscribed angle subtended by the same arc. So in this example, if we look at it to the left here, BCD, so this central angle, BCD, is actually twice the other ones. And that's just a fancy rule. Okay, so same here. If I draw an inscribed angle like I did here, let's say this one here, all the way across. If I then draw a central angle that has the same, that's subtended by the same arc, like this, the measure of the central angle would be twice the measure of the inscribed angle. And I'll show you a couple examples where the lines aren't so squiggly in a second here. All right, and just a special case to think about. A chord that runs through the center of the circle forms an angle that is 180, right? So a straight line makes this angle 180. So any inscribed angle subtended by the same arc would be 90, and this allows us to use Pythagorean to solve for missing sides. Okay, so although it might not look like it, this is a central angle, right? And as it gets wider, eventually we get to this central angle, which is just 180 degrees. And then the inscribed angle, remember, goes all the way across, and then that leaves this as 90. So it's a special case that we'll see in the textbook, and because when this is 90 degrees, when you know that's 90, you can use Pythagorean and solve for some missing sides. All right. Remember, just quickly, that the angles are named by the letters that form the endpoints and the vertex. Okay, so ACB is the central angle. So we start at A, go to C, go to B. So ACB is the central angle, and ADB is the inscribed angle. ADB. So just when we're keeping track, because some of these circles will have quite a few angles in them at once, and so it's just important to remember how exactly they are named. All right, let's try a quick example here. So it says point C is the center of the circle, so it tells us that, so we know that for sure. AEB is 35, and you can see they've labeled that for us here. All right, what is the measure of ADB? Justify your answer. And part B says, what is the measure of ACB? Justify your answer. Okay, so we look at this diagram here, and we're trying to find ADB. Okay, so how do we do it? Well, we know that AEB is 35 because it tells us, and more importantly, it shows us here. For these geometry questions, it's really important to either look at the picture that they give us or try and draw our own picture if there isn't one, because it's really a lot easier to do that than try and just solve it in our heads. So we know right away for part A that angle ADB also has to be 35. And why do we know that? Because this angle here is the same as this 35. And we can prove that because if it asks for a proof, they are both inscribed angles that are subtended by the same arc. So here's the arc here. They both share these endpoints. So any inscribed angle that goes all the way across the circle and back to those same endpoints would also be 35 degrees. Okay, I could draw 100 of them and they would work. All right, now part B, the measure of ACB is what? So ACB, if we look at our drawing here, ACB is actually the central angle. So it's the central angle, but it's still subtended by the same arc. So the rule was the central angle equals 2 times the inscribed. So what was the inscribed again? 35. So it's going to be 2 times 35 degrees, and that gives us 70 degrees. So ACB, the angle, equals 70 degrees. Okay. So just looking at this diagram one more time here, I'll just erase what I drew over top of. So one more time, ADB, this first part A, that is 35 because it is an inscribed angle, which means it goes all the way across the circle like this, and it has the same endpoints as AEB, which is the one they gave us. So like I said, I could draw 100 triangle looking things like this. As long as they are both angles that share this arc, they'll all be 35. Okay, and then for part B, the central angle, if we get a look at it more clearly, the central angle here, the rule is because it's subtended by the same arc, it's going to be 2 times the inscribed angle that they gave us. Okay, so 2 important words: inscribed angle, central angle, and I guess subtended, so meaning that they have the same endpoints. If you know those 3 things and how they work together, you'll be totally fine in this unit. All right, let's try example 2. It says point C is the center of the circle. They always have to tell you that because we can't just assume it goes to the center, because we could have a circle that looks like this and an arc through it, or a chord through it, like that. And it might look like it's kind of close to the center, but you can't say for sure unless they tell you, so just keep that in mind. So it's telling us that this is the center of the circle, so this chord goes directly through the center. AB equals 10 centimeters, so they've labeled it right here, it's 10 centimeters. And BD is 6 centimeters, so this other side of the triangle. What is the measure of ADB? Explain your reasoning. Okay, so let's just take a look at this circle again here. And we're trying to find ADB. So ADB, this angle. So what kind of angle is it? It is an inscribed angle, because it doesn't go to the center, it starts on the end of the circle, goes all the way across. Okay, so angle ADB, throw my pen away, angle ADB is the inscribed angle, because it goes all the way across. So let's look at this a little more closely here, and we're trying to figure out the value of it. So how many degrees is that angle? Well, we first have to ask ourselves, how many degrees is this central angle? So this angle here is how many degrees? Well, the central angle, I'll just make a note here, ACB, the central angle, is 180. We know that because it passes through the center of the circle, so it's a straight line across. Okay, we also know that the central angle is twice the inscribed, 2 times the inscribed. So if we work backwards, we can figure out here that angle ADB is 90 degrees. Okay, and we can kind of tell that by looking. This looks like 90 degrees. But the way to prove it is, because we know it's a straight line, it has to be 180. We cut it in half, and we can figure out that that's 90. Okay, so now that we know it's 90, we've officially answered part A. Now part B says, what is the length of the chord AD? So we're trying to find the length of this chord here. Justify your answer. So now this is no longer a circle problem, this is a Pythagorean theorem problem. Which means that because this is 90 degrees, this angle here is 90, we can use Pythagorean to solve for that missing side. So let's do that. Just clean up this circle here for a second. So remembering what Pythagorean is, switch colors here. A squared plus b squared equals c squared. And these letters mean nothing, like these A, B, C, D have nothing to do with this formula. Okay, that is simply a squared plus b squared equals the hypotenuse. Okay, so if we look at our circle here, a squared, so that's going to be 6 squared plus b squared, because we're trying to find out this distance here, equals 10 squared. They gave us c squared. So we'll solve that. 36 plus b squared equals 100. I'll minus 36 to this side, so I get b squared equals 64. And then my last step is to square root that. And I get b equals 8. And then because it started in centimeters, 8 centimeters. Okay, so this first part of the question here might seem a little irrelevant, but the whole point of that was to prove that this angle is 90. And when you prove that this angle is 90, that allows you to use Pythagorean. You're going to see that a lot in this assignment. Okay, so just look for that. All right, our last example here. Point C is the center of the circle. See, they always tell you. If they don't tell you, then they might be trying to trick you into thinking that it is. So just look for that indication. AB is the diameter. So AB is the diameter, goes right through the center of the circle. AD is 12 centimeters, BD is 5, and they've drawn it here. So first, they're going to ask us the measure of the angle. What's the measure of ADB? Well, if we look here, we can tell again, it's exactly the same as the last question. It's going to be 90. ADB equals 90. And that is for the exact same reason as the last question. Because this was 180, this is the inscribed angle, so it has to be 90. Okay, I'll just clean that up so we can see it a bit better. So part A is usually the first thing they'll ask us is that what's the measure of that angle to prove if it's 90. So we know it's 90 degrees. We're done part A. And because, if we need to explain our reasoning, it is 2 times the central angle, which was 180. So we know that ACB was 180 because it went all the way across. And so half of that, sorry, it would be 90. The central angle is 2 times the inscribed angle, not the other way around. So we can see that by cutting it in half. All right, so then what is the diameter of AB? So now we have a Pythagorean question again here. So we're trying to find the length of the diameter AB. So we're going to plug it in. A squared plus B squared equals C squared. And I realize that we're using the same letters, so again, it might be a little confusing. But this small ABC do not correlate to these big letters. So A, I'm going to pick this side. So it doesn't matter, either one of those 2 legs. So 5 centimeters, I'm going to square it, plus this will be B, 12 squared equals C squared. All right, so we have 25 plus 144 equals C squared. And then I get 169 equals C squared. Remember, our last step will be to square root both sides, and we'll get 13 equals C. And so what is this C? That's this diameter AB. So that's this side here. Okay, so our final answer is AB, or the diameter, is equal to 13 centimeters. And then the last thing to do is just to go over and just double check, does that make sense? So if we look at our original question, if this side's 5 and this side's 12, we know the hypotenuse has to be longer. So is 13 the longest side? Yes. And is it in the same sort of range of values as the other numbers? Yes. If we would have gotten like 1,000, you might want to double check it, right? All right, there we go. And this will be our first textbook assignment. So I'm going to post this assignment on the website as well. Take a look at it. It's just 10.1. And in a couple days, I will also post a solution key. So the point of these assignments is to practice the new math. So give it a try, check the answers, check the solutions when they're up there, and then feel free to message if you have any questions. So message if you have questions, and please, I do not mind at all. Don't get frustrated if you are finding that. Just do me a simple message and we will figure it out together. All right, thank you for listening. Hopefully this makes sense, and good luck with this part of the assignment.